This is going to be the last chemical change for the video today, and we're going to look at the reaction that occurs when you mix copper 2 chloride aqueous solution with sodium phosphate aqueous solution. Both these are ionic substances, so their ions are dissociated in solution, and we'll talk about that in just a minute. Okay, so what I have here in my test tube is a couple milliliters of the blue copper chloride solution. To that, I'm going to put up my white screen so you can kind of see what's going on here more clearly. So to this blue solution, I'm going to add our colorless sodium phosphate solution. We're going to see what happens. So as I add it in, you see kind of some goopy blue stuff forming here. And what that is a precipitate. So a solid is forming when I mix the two substances. We'll add a good squirt of this so that we can get some good separation here. I'm going to stir this up. And you can see really now it's really thick. You can see lots of solid here. I'll try to add just a little bit more sodium phosphate so we can get this maybe a little more. So what I'd like you to see is the separation. So we may have to let this sit and come back to it after we do some of the other explanation. But you can definitely see some of these solid particles are kind of sticking on the side of the test tube. So this is a precipitate formation. I think you can tell from the reaction that the precipitate is a blue color. And so if you kind of use your context clues there, if copper solution is blue and we formed a blue solid, you may guess that the copper ions are now in the solid, and you would be right. We'll talk about that in just a minute. So we'll let this sit a little bit and come back to it after we go through the whole explanation. Okay, so just like before, we're trying to look at all three levels, macroscopic, what you can see, particulate, so what's going on at the molecular level, and then symbolic. So again, I'm going to do my own drawing here. I'm really going to have to do a pretty good key for you because we got a lot of stuff going on here. For this model, just for ease, I'm going to leave out water. But you should note that water is definitely present in both cases because they're aqueous solutions. So this copper chloride aqueous is going to dissociate into its ions, Cu plus 2, and then 2 Cl minuses. For my key, copper ion is going to be open circle like before. Chloride is going to be closed circle. Okay, and then we have sodium phosphate, okay, which is here, aqueous. And so when it breaks apart into its ions or dissociates, you actually get 3 positive sodium ions and then a phosphate. And then this is the first time we've seen this type of thing. Well, the hydrogen carbonate was like this, but this is a polyatomic ion. What that means is more than one atom. They stay together as a unit, and they have a charge, so they're polyatomic ions. And so to make this easy, I'm going to show this as like a stripe, and I'm not going to show the P and the 4 O's just for ease. I'm just going to draw one thing to represent this. So I'm going to do kind of a big circle with hatches like that. And so that's what we're going to represent in our pictures. So if you think about, this is copper chloride, so I'm going to show 1, and then like this. And so what I've shown here, I think I'll draw maybe one more. Okay, so this is going to represent my copper chloride solution. There's 1 copper for every 2 chlorides, as you can see. And then for the sodium phosphate, kind of do the same thing. So you've got 3 sodiums, right? So there's 3 for every 1 phosphate. And I think that's all I'll draw there. I'll maybe draw one more. Kind of run out of room. So 3 sodiums. 1 phosphate. Okay, like that. So what we're going to do is we're going to keep up with our conservation of mass for this picture, just so you can kind of see what's going on there. Okay, so we're going to mix these together, and then we need to think about, okay, what can we make? And what's going on when these things react? You can look up here at your ions. This positive ion is going to join with this negative ion to form our solid. This negative ion could possibly join with this positive ion. The only thing is, if you look at this, you get sodium chloride, and I think from your everyday experience, you know sodium chloride is soluble. And so if these ions join up, they're just going to come right back apart. Okay? So let's look at this. This is what we're going to focus on. This is our precipitate. And we talked about this in an earlier video about how to write formulas. So if it's copper plus 2 and phosphate negative 3, the formula of your solid winds up being Cu3PO4 2. And so that's copper 2 phosphate. The formula works out like this because when ions combine to make a substance, the charge has to be neutral. And so there are 3 positive 2 coppers, that's plus 6, and there's 2 negative 3 phosphates, that's negative 6. So plus 6 plus negative 6 winds up being 0. So this is a correctly written formula here. So if you look at this formula, to make one solid, we need 3 coppers, okay? And we need 2 phosphates. So let's look up here. Do we have 3 coppers? Yes. 1, 2, 3. Do we have 2 phosphates? Yes. 1, 2. So let's look at what's going to happen here. I'm going to draw kind of a big oval so we can see. So remember, your solid is going to sink to the bottom. It's going to, your precipitate. So I'm going to try to draw this, and this is not going to be super accurate, but we're going to show all of our circles together here. And so we've got 3 coppers, right, and then 2 phosphates. Like I said, this is not really accurate, but it works for our model, like that. And so this is our solid. I'm showing it down at the bottom, okay? And so notice we've used up this, and this. So what's left over? So let's take a look. We have 6 chlorides, so we show them up here. 1, 2, 3, 4, 5, 6. They're still ions. They're still soluble. So they're up here in the solution, kind of floating around. And then we have 1, 2, 3, 4, 5, 6. Na pluses, right? 1, 2, 3, 4, 5, 6. Okay. And so this is our particulate level view of this reaction, keeping up with our conservation of mass, which you need to think about, but you don't always have to show in models. I wanted to show that for this one to kind of get us thinking about that. And so there's our particulate level view. Okay, so we're now going to look at the symbolic level, which we already did a lot as we were kind of going through the particulate level diagram. So we're going to start out, we're going to do the same thing. We're going to look at our overall, our complete ionic, and then our net ionic. Okay, and so we're going to start with our overall reaction. We've got copper chloride, which is aqueous. I'm going to leave out the aqueous symbol there just so I can have enough room. And then sodium phosphate, aqueous. This is a double replacement reaction. And so the positive ion in the copper is going to join with the negative ion in the phosphate. We already talked about how you would write that formula in the previous example. Okay, and then sodium, which is +1, will go with chloride, which is -1. So you only need one of each to make a 0 or neutral compound. So this is your reaction right here. Now, if you look at this, it's pretty clear it's not balanced. So let's go through how to balance this out. So I've got 1 copper here. I've got 3 here. And so I might start out by putting 3 to make those balanced. That gives me 3 times 2, which is 6 chlorines. I only have 1 chlorine here, so I'm going to put a 6 in front to make them equal. I've got 3 sodiums. I've got 6 here. So how can I turn a 3 into a 6? I can multiply by 2. Okay. And now the good thing about polyatomic ions is you do want to treat them as a unit, especially in balancing when it's on both sides. And so instead of breaking this down and saying that I have 2 phosphoruses and 8 oxygens, I'm simply going to say that I have 2 phosphates, because phosphate is PO4. So I have 2 phosphates, or 2 PO4s, right? And if you look over here, how many PO4s do I have? I have 2. So that's balanced, and you're ready to go. So this is my overall reaction, balanced out perfectly. And then we're going to do our total ionic. So remember, aqueous, aqueous, solid, okay? So this is our precipitate right here. Our PPT precipitate, it is a solid, S. And so when I come down to write my total ionic, I'm going to keep this together because it's not aqueous anymore. It's not soluble, so it's not ionized. But everything else is soluble, so I'm going to break it up. And so this is going to break into 3 copper ions and 6 chloride ions. This will break into 6 sodium ions and 2 phosphate ions. Our precipitate we will keep together because it is not soluble, it's not ionized. And then salt, which we all know is soluble, will break apart. And just like before, when we did our net ionics, what we did is we crossed out things that didn't change. From the particulate level diagram, you could see that the colored in circle, which was the chloride, and just the striped circle, which was the sodium, they didn't change from beginning to end. So you could tell from the particulate level that the chloride and the sodium ions, they don't change. And you can tell that from the symbolic level as well. That is something you definitely don't see at the macroscopic level. And so here, 6 chlorides, we can cross those out, they don't change. 6 sodium ions, same, they don't change. And so our net ionic equation represents only the ions that changed, and it's the ions that reacted to form the precipitate. So our net ionic winds up being 3 copper ions plus 2 phosphate ions yields our solid, which is copper phosphate. And since we kept up with our coefficients all the way, it's already balanced for us. It's balanced for us in terms of atoms, 3 coppers, 2 phosphates, 2 phosphates. It's also balanced in terms of charge, which is important as well. 3 times positive 2 is plus 6. 2 times negative 3 is negative 6. So it's a 0 charge here, and then obviously a 0 charge here. And so it's our net ionic equation for what happened. You can definitely see that we've had some settling out, and really kind of neat. You can see that clear, colorless solution at the top, and you might say, well, what kind of solution is that? And if you look up here, it's a saltwater solution. And so what's present in the clear liquid there, clear solution, is dissolved salt and water. And then all this blue, which if we let it keep sitting will settle even more, is your copper phosphate solid. We could filter it out and do all that if we wanted to.